Alright, we are going to review what's called the discriminant. So recall from an earlier video that this ax squared plus bx plus c is what we call standard form of a quadratic. And also recall that here is the quadratic formula, which is used to find roots. And typically we only want to use the quadratic formula if a quadratic cannot be factored. If it can be factored, you don't want to waste your time using the quadratic formula. So I want you to focus on what is underneath the square root. Okay, this b squared minus 4ac. This is what we call the discriminant. It tells us about the roots. So first and foremost, remember that it shows up in the quadratic formula underneath the square root. Okay, so let's jot down that in general, the discriminant is going to tell us about the roots. Okay, so it tells us about the roots of a quadratic. Okay, now let's just use common sense here. Think about what it would mean if b squared minus 4ac were less than 0. In other words, if it were a negative number. Hopefully you're thinking, well, hang on, I can't take the square root of a negative number. So that would be undefined, which means that we have no real roots. Okay, so a negative discriminant yields no real roots. If you're wondering, well, what could that possibly look like? Well, a couple different scenarios. All right, you can have something opening up or opening down, but either way you look at it, it is not going to hit the x-axis, right? Y will never be 0. Okay, so that's the first case where the discriminant is negative. You just need to know that we have no real roots. I suppose you can say it means we have imaginary roots, but in this course we don't do anything with imaginary numbers. So at this point you just need to know that we have no real roots, which again means the parabola is not going to cross and hit the x-axis. Okay, our next case here. If our discriminant is equal to 0, this means we have two equal real roots. Or another way of saying that is to say we have just one unique root, or one distinct root. And let's just think about why this is. If you go back to the quadratic formula for a moment, plus or minus, if the square root of b squared minus 4ac, if that is a 0 underneath there, what you're left with is just negative b over 2a, okay, which happens to be your equation for your axis of symmetry, okay. So graphically, what is happening here is you have a quadratic touching down in one spot. Notice how the axis of symmetry would go right through it. So not only would it be the equation for your axis of symmetry, but it would also be where your parabola touches down. Okay, and of course you can draw it in a different manner as well. You could draw it like this if it's opening down. Okay, but it would still be the case that the axis of symmetry is there, okay, running through that root. Okay, so you can see there's one root, okay, there's only one spot where it's hitting the x-axis, okay. So if the discriminant is equal to 0, you have one distinct root. Sometimes we say two equal roots, and what that is going to stem from is when we factor something. If you were to think about this quadratic, x minus 4 times x minus 4, if we were looking to find the roots here, you would have two equal factors, which means we would then have two equal roots. Well, it would be redundant to put both of those in our solution set, so we just say that our solution is x equals 4, so there's one unique root there. Alright, in our final case here, if our discriminant is greater than 0, that means we're going to have two, sorry about that, we're going to have two different real roots. So graphically it's going to look something like this, right? There's a root, there's a root. Or maybe it looks something like this, okay? So you have two distinct or different real roots. So understand why that happens in your quadratic formula. This square root is not going to disappear if you have a number greater than 0. Okay, so this plus or minus is going to remain. Remember, in the case where it was 0, you're really just looking at plus or minus 0, so we were able to drop the plus or minus. But this is going to be a positive number, which means that plus or minus is not going to disappear. So it's going to give you two different answers for x. Okay. Now, one thing to add to that. Alright, so if our discriminant is a perfect square, so we're still talking about a number greater than 0, okay? A perfect square such as 1, 4, 9, 16, 25, 36, 49, so on. If you have a perfect square, then we can also say, so in addition to saying that we have two different real roots, we can also add that we know that the roots are going to be rational numbers, okay, as opposed to irrational numbers. All right, so that means you might get nice clean integers. You might get a clean fraction like 3 over 7. Okay, if it's and think about why. Okay, this b squared minus 4ac again is underneath the radical. So if this number underneath the radical, all right, if this piece right here is a perfect square, you're square rooting it, which is going to give you a nice clean integer or a nice clean fraction. Okay, but the bottom line is you're going to end up with rational numbers in the end. Okay, when you do your quadratic formula. So if it's a perfect square, you're going to get rational numbers.